Okay, so we're going to take a look at a little bit about ions, and I like to call ions the atom's quest for nobility. As we know, most of our elements are not found on Earth by themselves. They're usually locked together in chemical compounds. Part of this reason is when the elements get together, they are much more stable. All the elements would love to be as stable as the noble gases. Remember, the noble gases are found in group 18 on our lovely periodic table. Let me highlight those for you right here. And the reason they are so stable is that they have a full valence shell of electrons. This you might remember from ninth grade. The magic number is 8. So if you have 8 valence electrons, then you will be a much more stable atom. Except for helium. Of course, we have our little exceptions. Helium only has 2 valence electrons, but energy level 1 can only have 2 electrons. So that is also very stable. All the rest of the elements, all the rest of these elements would like to be as stable as the noble gases. And so they will try different things in order to become more stable. They will share electrons, give electrons, and take electrons. And that's the basis of bonding, which we'll get to later this year. But for right now, we'll take a look at one of these situations in which we will lose and gain electrons, and that is the forming of ions. So the first scenario is if we gain electrons. If you gain electrons, you will become a negative ion, anion. And remember that this is being done in an effort to get up to 8 valence electrons like a noble gas. So if you look at chlorine on the periodic table, it's in group 17 right next to the noble gases. So if you look over here, right here, it's a halogen in group 17. All the halogens are 1 electron away from being a noble gas. So they would like to gain 1 electron. And you can see that through chlorine's total electrons. Chlorine has 17 electrons and 17 protons in an electrically neutral atom. Well, if it gains 1 electron, then it will have 18, which is just what argon has. It has attained nobility, and it is much more stable. By doing that, though, since it still has 17 protons, it has an extra electron, so now it is going to carry a negative 1 charge. That's a little complicated for some people. Since you are gaining electrons, you think, oh, that's a plus situation, gaining. But remember, electrons are negative. When you gain something negative, you will take a negative charge. Oxygen is 2 groups away from the noble gases. Oxygen has 8 total electrons. If it gains 2 more, it'll end up with 10, which is like neon. Yay! Noble gas. And so gaining 2 electrons will give it a negative 2 charge. Arsenic has 33 electrons. If it gains 3, it'll have 36 like krypton, and it will end up stable as well. These are all examples of anions, and typically we find that the nonmetals are the ones that are going to be gaining electrons and forming these negative ions. A metalloid here and there now and then, but predominantly for us we're going to be looking at the nonmetals doing that. On the other side, we could lose electrons. And if we lose electrons, we'll become a positive ion. And these are called cations, not cations, cations. And again, we're doing this in an effort to become like a noble gas. When you lose valence electrons, underneath them is a nice full shell of electrons. And that is a stable situation. The noble gases, the alkali metals, for example, all have 1 valence electron. Cesium is an example of an alkali metal. They would love to lose that valence electron because underneath that energy level is a full energy level. So cesium with 55 electrons, if it loses 1, it goes down to 54, which is just like xenon, a noble gas. Yay! But again, it still has 55 protons, so since we lost one electron, we will have a plus one charge. Again, a little confusing, but when you lose negativity, you'll become more positive. So when you lose a negative electron, you get a positive charge. Calcium has 20 total electrons. When it loses 2, it goes down to 18 electrons, just like argon. Nobility achieved. But again, you're going to have a plus 2 charge because you lost 2 electrons. Aluminum, 13 electrons, lose 3, you have 10, just like neon, but you have a plus 3 charge. All of these are metals, and so we can say that the metallic elements, are the ones that are going to lose electrons and become positive cations. Last little note about ions is ionic size. For lack of a better analogy, I call it atomic weight management. When you are a metallic atom and you lose electrons to become a cation, those cations are smaller than the metallic atoms they started as. On the other side, if you're a non-metal, a non-metallic atom, and you gain electrons to become an anion, then you're going to get bigger because you're adding electrons into the electron cloud. And like I say, I call it weight management. You know, if Mr. Sen does a good job and has salads all week and exercises, he can lose some weight, and he would get smaller. However, Mr. Sen usually has some wings when he's watching an Ohio State game, maybe some pizza when he's watching the Browns game, and he's going to gain a little weight. He gets bigger. So it's the same kind of scenario here with the cations and the anions. Again, the cations, these metallic atoms, lose electrons. They basically lose an energy level of electrons that are an energy level that's occupied, so the electron cloud gets much smaller. Whereas the anions, you add electrons in, and they get bigger than the atoms they started as. All right, next we will do periodic trends. See you then.